And we are going to start today, and we're going to see how far we get. I'm not saying that we're going to finish everything today, because we might not. Okay, I hope we do. I think we will, but there's a lot of stuff to get through today. Okay, now what is the next 2 weeks going to look like? Okay, here's the next 2 weeks for the pace chart. This week, no lesson tutorial. I didn't send one out because it's like there's no new lesson. We have a recorded main lesson. There's no examples. There's no practice this week. You don't have to. Now, there is a week 17 exam review, and that's what we're going to work through today. So if if you stick around today, we're going to try to get through all of the problems. Now, if you took a look at the exam review, and if you took a look at the exam, they should look almost identical. When I did the exam review, I had the exam review open and I had the exam open. And when I found a problem for the exam review, I found basically the same type of problem for the exam. So when we go through the exam review today, it should be almost identical to the exam. Now, do you have to do the exam review and turn it in? No, you absolutely do not. Okay? It's not counted in as your grade. What do you have to do? By the end of next week, you have to have the exam done. Yes, the exam is all multiple choice. However, you only get one attempt. You do not get 2 attempts. You do not get 3 attempts. You cannot make corrections to it. You have 1 attempt on the exam. Okay, that's it. So make sure you know what you're doing when you turn it in. Okay, so now the exam, so after today, we'll have the exam review done. You can go back and you can just, instead of doing the exam review, you can just go right to the exam. How much is the exam's worth? I count it as just another assessment. So let's say target 1 had 7 assessments in it. This would just be the 8th one, and I would just count it as the last one. Okay, so it's not going to change your grade by a lot, but if you do get an advanced on it and you had a bunch of proficients and then that advance at the end, I look at the end one a little bit more. It's like, oh, okay, they really understand what they're doing, so I might just bump your grade up. Okay, all right, so let me give you the Desmos presentation here for this, and we will just work through. That's all we're going to do today, is we're just going to work through the exam review. Now, you don't have to open it up, and you don't have to do it if you don't want to. It's it's an open book. You can look at anything you want for the exam. Yeah. So there are 3 different exams. Yep. I think there's 10 questions on each one. There's 3 different ones. Why is there 3 different ones? Because there's 3 learning targets. So there's 1 assessment that goes along with each one. Okay. And as I said, when I made out the exam review, I basically made the exam at the same time. So when I found 1 question for problem number 1, I will tell you it's going to be very similar to the first problem on the exam. Okay, that's how I made it. All right, so let me share my screen with you guys here so we can work through these problems. All right, so share application screen. Let's see here. That's not it. That's not it. Uh-oh. I'm not seeing what I want to share with you. Oh, that's not it. Huh. Wow. Let me cancel that. Let me go here. Okay, so it's all right. Let me try this again because I wasn't seeing what I wanted to share with you guys. Wow. Something is not working correctly here. Chrome tab. Huh. Oh, maybe that's why. Huh. I have it called something different. Okay, let's try this. All right, let's try that. Okay, so do you guys see the learning target number 1 graphing? Okay, so here it is. So this is learning target number one. Learning target number one in our class was graphing. Okay. So let's do problem number one. So let's jump over and do problem number one. Number one, it says which inequality best represents the domain of the function. Okay. Now remember, domain is all of your x values. So when I do domain and it's already graphed out for me, all I do is I just look at this and I say, okay, what is the farthest over to the left that I go? So this looks like as far over to the left as I go. How far over to the right do I go? And it looks like this. And they're open dots, so I know I can't have an equal sign on it. So it looks like -3 is less than x, which is less than 6, I think. So that is it. Yep, closed dot would mean equals. Correct. So the answer should be letter B. Now, I will tell you, does anybody have the exam open right now? Okay, Samantha, in exam number one, the practice one. Okay, I'm looking for the real exam. Does anybody have the real exam open? Yep, yeah, open up the real exam. And the first problem should be something very similar to that. It should be a domain or range question. Okay, I just want to make sure that I'm not, I want to make sure you guys know that I'm not kidding. A range question, okay? So as I said, your exam is going to look very similar to the practice. So if you understand the practice, you'll do well on the exam. Okay, so problem number two. Let's go to problem number two. Number two, it says a function is graphed below. Okay, which of the following best represents the range of the function? Well, when I find the range, that's the y values, isn't it? So all I do is I look for the lowest point on the y-axis and the highest point on the y-axis. This is a closed dot, so the lowest point looks like -2, less than or equal to y, because it's my y value, because it's a domain. And how far up does it go? It looks like it went up to 2, but that is an open dot. So it looks like, looks like letter C. Nope, not letter C. Oh, wait. It looks like letter A, if I'm looking at it correctly. Okay. So that's the difference between domain and range. Domain is the x's, the range is the y's. And that's, you know, when you look at the exam, it's basically what I'm asking for. I want to know, do you know domain and range? Domain and range. All right, number three. Number three, it says, how would the graph of the function, okay, so now if you remember back, way back to like week 2 or 3, we talked about transformations of graphs. How would the graph of the function y is equal to x squared minus 8 be affected if the function were changed to x squared minus 3? So if I think about this, x squared minus 8 would be a graph that looks like this at -8. It goes down to -8. And the other graph just goes down to -3. So that graph would be exactly the same, but only goes down to -3. So that's what would be going through my head. So how does it change? D, the graph would shift 5 units up. It's absolutely correct. Okay, I would go along with D because I'm going from -8 and I'm shifting the graph because it says that x squared minus 8 is the original graph. And then we're going to go to the graph of x squared minus 3. So we're really shifting that graph up 5 places. Are any of these problems that difficult? Not yet, right? It's just basically reviewing the kind of stuff, you know. It's like, okay, how do I shift the graph? Well, if it's a number on the outside, it's going to shift it up and down. Okay. I did not try to make this a hard exam. I just tried to cover all the material that we had. Question number 4. It says compare the graph of x squared and the graph of 2x squared minus 5. Okay, so I think about it. I know the graph of x squared looks like this. And then 2x squared, I know is going to be thinner, and then minus 5 is going to go down. So if I had to graph this, 1, 2, 3, 4, 5, but then it's going to be thinner also. So my graph would look something like this. So I went from the blue graph to the red graph. So what's happening there? Okay. So we would write letter B. It's narrower and it's translated down, right? And that's why we're reviewing. This was a long time ago. This was transformations were, way early in the semester, way early. Now, if that was a 1/2 x squared, then it would be wider, right? So if this was 1/2 x squared minus 5, then this would be a wider graph. Okay, so the number greater than 1 makes it thinner. The numbers less than 1 makes it wider. All right, problem number 5. It says a graph the absolute value equation. So I have the absolute value of x plus 4. Which one of those graphs represents the graph of x plus 4? The absolute value of x plus 4. Okay, does anybody know? Letter B. I agree with that. Yeah. I'm going to go with letter B because letter D, it would look like the equation would be this. For letter D, it would be y is equal to the absolute value of x plus 4. That plus 4 means it's moving up. Since it's inside the absolute value, it always shifts it left or right. Well, it always shifts it opposite, remember? So it's going to shift it 4 places to the left. So my answer is going to be letter B. So if it's inside an absolute value, or if it's inside parentheses, it's going to move it left and right. Yeah. So that if it's on the outside, it's going to shift it up or down. Thank you, Samantha, for explaining that. Thank you. So those are the things that you look at. If it's inside absolute value or the parentheses, it's going to move left and right. If it's on the outside, it's going to move it up and down. All right. Number 6. Holy moly, I barely can read this thing. It says, what is the graph of the polynomial function? Okay. Now, when I look at a problem like this, and I think it says x minus 1, x plus 1, and x minus 4. Okay, when I look at a graph like this, first thing I do is I look at, okay, where does it cross the x-axis? It's going to cross at x equals 1. It's going to cross at x equals -1. It's going to cross at x equals 4. Now, what's the end behavior going to look like? Well, this is a first degree, first degree, first degree. So this is a third degree polynomial, and it has a positive leading coefficient. So that means the end behavior is going to look like this. It's going to go up on the right-hand side. It's going to go down on the left-hand side. So it looks like B could be my answer. It looks like D could be my answer. So the only thing I have to look at now is which one crosses at 1, -1, and 4. Well, looks like letter D crosses at 1, -1, and +4. So it should be D. Right. And Samantha, you're absolutely right when you're doing multiple choice questions. It's like, hey, cross off the ones that it can't be, because we know what the end behavior has to look like. So I know it can't be letter C and letter A, because the end behavior doesn't even look like that. Okay, so sometimes it's like, okay, cross off the ones that can't be, and then what can it be? So far, there really hasn't been any work that you had to do, right? All of this is stuff that in your head you should be thinking about, and oh, okay. So there really wasn't a lot of work that has to be done on these problems. It's just, do you recall, end behavior, what the graph is going to look like, where does it cross the x-axis, and stuff like that. Okay, so as I said, this is not the hardest exam in the world, but it does go through a lot of stuff. All right, next problem. It says, which of the following polynomial functions could have the graph shown? Okay, so I know that the end behavior, it looks like it has a first degree here. What degree is this? When it touches the graph and goes back up, what degree is that? Yes, it's a 2 because it bounces. Absolutely correct. It bounces there. Very nice. So this is a first degree because it crosses. Second degree here. So this is a third degree polynomial. And it has, so I'm looking at x, so I have x plus 2 because, and then x minus 1 squared. Why did I put square there? Because it bounces. That means it has a second degree there. It hits, but it does not cross. So my equation would be this. Was that hard to write an equation for that? Absolutely not. Okay, so it looks like A should be my answer, right? Yeah. Kind of cool when you start realizing what's happening in these graphs. It's like, oh, that was pretty easy to write an equation for that thing. Love these types of problems. Well, I love this type of an exam because it really, it's not one that you have to do a lot of work, but you really have to understand a lot of material. All right, next question. Find the slant asymptote, if any, of the graph of the rational function. All right, so how do we find slant asymptotes? Okay, what do we have to do to find a slant asymptote? Division, right? And we usually use synthetic division, right? Special division? I'm going to say synthetic division. All right, so I'm going to use synthetic division. So I've got 1, 3, -6. And since this is x minus 3, I use the positive 3 in there. I always use the opposite. Bring down the 1. 3 times 1 is 3. 3 plus 3 is 6. 18. And remember, we don't care what the remainder is. This is what's my answer. So 1x plus 6. Done. That is a slant asymptote. So letter A is correct, right? Synthetic division really helps out there. Don't want to do long division there. Synthetic made it fairly easy to do. All right, next question. What is the horizontal asymptote here? Okay, what is the horizontal asymptote? Okay, so now we have to start talking about. Yes, the slant asymptote is when the highest power of the bottom is 1 less than the highest power of the top. Correct. Very good. Boy, Samantha, you really understand your math. Okay, what about horizontal asymptotes? The last one was A, x plus 6. Now remember, horizontal asymptotes, there's 3 different ways it could be. It could be 0, it could be infinity, or it could be a number. Okay, and it all depends on the highest power on top and bottom. Letter D, y is equal to 0. I agree with that. Okay, because the top or the bottom is bigger than the top. Remember, if we did it this way, if the top is bigger than the bottom, so big over small, we have infinity as our answer. If the top is smaller than the bottom, and what do I talk about small or big? I'm talking about the exponents. So this one on top, 2 on bottom. So that means y is equal to 0 is my horizontal asymptote. And if they're the same, so if I had something like x squared, 2x squared plus 4 over 3x squared minus 5, if they're the same, you take the coefficients in front. So that would be y is equal to 2/3 would be the horizontal asymptote. So that's the 3 different ways you could find a horizontal asymptote. Okay. Yeah, you're absolutely right. The bottom is heavy, the line is steady. Awesome that you remember that. All right. So let's see here. I think this is the last problem. So identify any horizontal asymptotes of the function. Okay, so what would the horizontal asymptote be for this function? Letter C, y is equal to 2. That is absolutely correct. Why? Because the powers are the same. So if the powers are the same, we just take the exponent or the leading coefficients. So that's 2 over 1. So that's y is equal to 2 over 1, which is y is equal to 2. Done. That is the first part of the exam. Okay, dealing with those types of problems. Yeah, exactly. 1/3 done. That is absolutely correct. All right, so then learning target number 2 is solving. This one's a little bit tougher because we've done a lot of solving this semester. We've solved quadratics, we've solved rational functions, we've solved radical functions, right? And in the last couple of weeks, we've done this most of our solving, right? In the last couple of weeks, we've been doing solving of all those types of problems. The last answer, C, y is equal to 2. Thank you, Joseph. Excellent. All right, so problem number 1 on the second learning target. It says solve to find the inverse. Okay, so now this is going to take a little bit more work, okay? The first part of the exam, there wasn't a whole lot of work to be had, right? Now somebody said, yeah, Samantha, absolutely right. Your first step, just flip-flop the x and y around. When you're writing an inverse, you just flip-flop. So this is really y is equal to 7x minus 5. So I'm going to flip-flop this, x equals 7y minus 5. And then if I solve for y, I have the inverse. I'm going to add 5. So x plus 5 is equal to 7y. Then I'm going to divide by 7. So y is equal to x plus 5 over 7. Now, they don't have it written that way. So this 7 goes to both terms. So this would be 1x over 7 plus 5 over 7. That would be my inverse. Okay, so I would go with letter D for my answer. Okay. So a little bit tougher on the second learning target because we're solving. Problem number 2, what is the inverse? Okay, again, okay, I'm going to let you guys do this inverse. I can't do it in my head. Yeah, and sometimes you can't. Now, do you have to show your work on the semester exam? Nope, you do not. Do you have to do the week 17 formative this week, the exam review? No, you do not. Right. So the only thing that is due from you guys in the next 2 weeks is the semester exam. That is it. Okay. So in this problem, same concept. I'm just going to rewrite this to start. Y is equal to 2/3 x plus 10. I'm going to flip-flop the x and y. And then I'm going to solve for y. So I'm going to subtract off 10. So x minus 10 is equal to 2/3 y. And then I'm going to multiply through by 3/2 because that's how you get rid of a fraction. So I'm going to multiply everything by 3/2 on both sides. So my answer would be 3/2 x minus 10. That would be my inverse function. So that would definitely be A, correct. So writing inverse functions, just flip-flop the x and y around, and then solve for x. All right, next problem. Okay, so I forgot about absolute value problems. So we solved quadratics, absolutes, radicals, and rationals. Okay, so I would definitely subtract off 2 from both sides. Good. So if I subtract, I'm gonna rewrite this way. Okay. Oops, that was a positive. So I'm going to subtract 2 from both sides. It's a good step. But I still have -1 in front. So I would divide through by -1. So I end up with the absolute value of 2x minus 5 is equal to -5. I can stop right now. Why can I stop? Because I know an absolute value cannot equal a negative number. There's no way you can get the absolute value of 2x minus 5 to equal -5. So there's no solution here. It is letter A. Love hash browns. Now, do we put syrup on the hash browns? Syrup on hash browns are so yummy. My wife always puts cheddar cheese on hers. I like syrup. Don't want your laptop to get sticky. Gotcha. All right. Next question. We have use the square root property to find all the real or imaginary solutions to this equation. Okay, so I've got x squared minus 225 is equal to 0. I want to get the x squared by itself, so I'm going to add 225 to both sides. So x squared is equal to 225. I'm going to take the square root of both sides now. X equals plus or minus 15. So I should have a positive or negative 15 for my answer there. So letter D. All right. Number 5. It says use the square root property to find all the real or imaginary solutions. Okay, so this time I have 8. I'm going to put x there plus 9 squared is equal to 4. Now, if you remember, when we dealt with absolute values or squares or radicals, we always have to isolate the square or isolate it. Well, this time there are no numbers in front or behind. They're all inside the parentheses. So I can take the square root right away. So if I do that, I end up with 8x plus 9 is equal to 2. I also end up with 8x plus 9 is equal to negative 2. Because when you take the square root of both sides, it's going to be positive or negative. So now if I subtract 9, I end up with 8x equals negative 7. Oops. So x equals negative 7 over 8. In this one, if I subtract off 9, I end up with 8x equals negative 11. So negative 11 eighths would be my second answer. So negative 7 eighths or negative 11 eighths. I would end up with letter D for my answer. Okay, is this stuff coming back to you guys? No, you don't. You wouldn't always get two solutions. There are a couple times where you'll just end up with one, but most of the times you will end up with two solutions. Okay. All right. Next question. Find the real or imaginary solutions by completing the square. Oh no. Now, obviously, you don't have to show your work. So completing the square, if you use another method, I can't force you to do completing the square. I can't see what you're doing. So but I'm gonna do it by completing the square. So I've got a squared minus 10a plus something is equal to, and then I'm gonna add the 24 to this side just to move it out, and then I'm gonna add the same thing to this side. Take half of 10, which is 5. I'm gonna add 25. So if I add 25 to this side, I have to add 25 to this side. This factors to a minus 5 times a minus 5, so I just write it this way, is equal to 49. Take the square root of both sides. Now I end up with a minus 5 is equal to plus 7, and a minus 5 is equal to minus 7. Add 5 to both sides, a is equal to 12. Add 5 to this side, a is equal to negative 2. Uh-oh, I did something wrong. What did I do wrong there? I don't have, did I mess up here? So if I add 5, that gives me 12. Oh, there it is, way over here. I didn't see letter D. Whew, I thought I messed something up there. yeah, it's letter D. I did not see the answer. I didn't see letter D though, way over to the side. Phew, I was getting a little worried that I solved the problem wrong. Heaven help us if the teacher can't even answer those questions. All right. Next question. we have solved the equation and checked the solution. Whew. Now, this is supposed to be a rational problem, right? But in a problem like this, when it's just a fraction equals a fraction, I would just multiply across on the diagonals. So I'd end up with 5x plus 1 is equal to, and if I multiply this way, I'd end up with 1x plus 2. And then that would give me 5x plus 5 is equal to 1x plus 2. Move that 1x over. So I'd end up with 4x plus 5 is equal to 2. 4x equals negative 3. X equals negative 3/4. And I don't get an answer like that. What the heck happened here? So if I subtracted 1. Huh. Oh, I should have subtracted 5. Oh, no. So if I subtracted 5, I get negative 3. Okay, where did I make my mistake? Oh, was it a negative 1? Ah, that'll make a difference, won't it? So this is negative 1 up here? Okay, so that's a negative 1 there. That's going to give me negative 1x minus 2. So I'm going to add 1x to both sides. So that'll give me 6x plus 5 is equal to negative 2. Subtract off 5. 6x equals negative 7. Divide through by 6, x equals negative 7/6. Okay, that makes more sense. I get an answer. No, I just scribble. No sense of erasing. I don't want to use up all my eraser. All right, next question. What is the sum of all the solutions of the equation? Now, some of you are probably saying, man, I think I've seen these problems before. Yeah, where do you think I got them from? All right, so in this problem, I think I'm going to multiply by 2, x plus 1, x minus 1. Yeah, that looks like right. To get rid of the denominators, that is absolutely correct. So, oops, I'm on the wrong page here. I want to change my thickness of my line. So I'm going to multiply x minus 1 times 2x minus 1x plus 1. Plus, and then I have 4, and then I have x minus 1, x plus 1. Minus 5, x minus 1, x plus 1. And that's over, this was x plus 1, this was over x minus 1, and this was over 2. That was it. There should be a 2 in front of there to each one of these. So here, the x plus 1's cross off. So I'm left with 2, x minus 1, x minus 1. Ugh. Plus, here the x minus 1 is going to cross off, but I still have that 2, so that's 8 x plus 1. A is equal to, and here, only the 2 crosses off, so I'm left with 5 x minus 1 x plus 1. Yikes. Okay. Not a really nice problem. So the next thing I would do is I would just multiply this through. Well, x minus 1 and x minus 1, that's going to give me x squared minus 2x plus 2, and then I have a 2 on front. So that's going to give me 2x squared minus 4x plus 4 plus, and this over here, that just gives me 8x plus 8 is equal to, and then here, x minus 1, x plus 1, I have a 5 in front of that. So that's going to be x squared minus 1, right? Times 5, so that's 5x squared minus 5. Bring the 2 over, so that gives me 3x squared over here. I have a negative 4x and an 8x. That gives me 4x. I'm going to bring that over here. And now I don't even see what I have there. Oh, boy. So I'm going to end up with 3x squared minus 4x. And I'm going to bring that 8 over, so that's going to be minus 9. Is that right? Did anybody do this? Is that 3x squared minus 4x? How did I get the squares? I'm not sure what you mean by the squares. All right. So let's redo this. Get rid of that. Get rid of that. Okay. So let's try to do this a little bit cleaner so it's a little bit nicer. So I've got x minus 1 over x plus 1 plus 4 over x minus 1 is equal to 5 over 2. We said that the common denominator was 2 x plus 1, x minus 1, right? So I'm going to multiply every single thing by 2. Let me change the color here. 2 x minus 1, x plus 1. And then here I'm going to multiply by 2 x minus 1, x plus 1. And here I'm going to multiply by 2 x plus 1, x minus 1. Okay? So I start crossing things out. So I'm going to cross this out. So I'm left with x minus 1 times 2 x minus 1 plus, and here I'm going to cross out the x minus 1. So I'm left with 4 times 2, which is 8 x plus 1. And here I'm going to cross out the 2, so I'm left with 5 x plus 1, x minus 1. Okay? So far, so good. Now, it's still not an easy problem, right? Because I've got to get rid of those parentheses. They're going to cause some problems. So I have to multiply this out. So this is going to be x minus 1 times x minus 1 times 2. So I'm just going to rewrite this as 2 x minus 1 times x minus 1. Well, if I FOIL here, I know that I get, because I can do this in my head, x squared minus 2x plus 1. Okay, that's what you get when you multiply x minus 1 times x minus 1. So I have a 2 in front, so that's going to be 2 x squared minus 4x plus 2. Okay. Plus, now I have this, so I'm just going to multiply it through, so that's 8x plus 8 is equal to, well, x plus 1, so I have 5, x plus 1, x minus 1. Well, this is a difference of 2 squares. If you do FOIL on it, you're going to end up with x squared minus 1. Okay, you can FOIL it out. This is, oh, yeah, it's going to be x minus 1. So you have a 5 in front of that. So that's going to give you 5x squared minus 5. Okay, and now it's just getting all of your variables on one side. And if I do that, I'd bring the 2x over. I probably would combine these first. So that gives me 4x on the side. So those are gone. That's a plus 8 here and a plus 2. So that would give me a plus 10 on this side. And then I'm going to subtract the 2x squared off. So that gives me 3x squared minus 4x minus 15. I think that's right. And then I would have to use the cheater method. So what two numbers? So that would give me 3x, and that's negative 45 on the outside. So what two numbers multiply negative 45 and add up to negative 4? Well, that's going to be negative 9 and 5. So minus 9 plus 5. So my 2, and then I still have to divide by 3. So that gives me x minus 3. 3x plus 5. So now, what are my solutions? My solutions are positive 3 and negative 5/3. But it asked, what is the sum of our solutions? So I'd have to change this to 9/3. So that would give me 4/3. Whew, that was one heck of a problem. You talk about so many different things in there. I mean, you've got a factor, you've got to get rid of the lowest common denominator, you've got to add a fraction together. Whew. Yeah, there's a lot of things in there. All right, we got to get going or else we're never going to get to the last part. Solve the equation for x. Well, this is what we just finished up doing, right? So I have radicals on both sides, so I'm going to square both sides right away. Well, if I square the left-hand side, I end up with 3x plus 2. If I square the right-hand side, that gives me 9, because I have to square the 3, 2x minus 2. So if I multiply through here, I get 3x plus 2 is equal to 18x minus 18. Bring the 3x over here, so that gives me 5x minus 20. Factor out a 5. If I factor out a 5, I end up with this. So my solution should be x equals, that didn't work out. Oh, I'd bring the 20 over here. If I'd get 4. Why did I mess up again? Looks like I messed up again because I don't see my answer here. Huh, where did I mess up? That's where I messed up. All right. So let's see here. So I subtracted 3x from 18x. I should end up with 15x, right? That's where I made my mistake. So if I bring the 20 over here, I end up with 20 equals 15x. Divide through by 15. I end up with x equals, what is that, 4/3? That makes more sense. Yeah, even your teacher can subtract incorrectly. All right, I think we have one more problem on this section. Solve the equation for x. Okay, very similar to last week. I would add 3 to both sides, so I'd end up with the square root of x minus 4 is equal to -2. Then I could stop, because I know you can have a radical equaling a negative number. So done. I can stop right now. All right. Ooh, I think we go on to the next section now. The next one, learning target. Number 3 is to evaluate and simplify. So it says evaluate the expression and write the result in the form a plus bi. So now we're talking about imaginary numbers. And remember, the I is just like any other variable until you have I squared. And if you have I squared is equal to -1. Learning target number 3 is simplify, evaluate, and simplify. So this one, we're just basically simplifying this thing. So if I multiply this through, I have 4 plus 7i times 7 minus 3i. So this is a lot of foiling. So 4 times, I'm just going to multiply through here. So that gives me 28 minus 12i. And then I'm going to multiply here. So that gives me 49i minus 21i squared. But I squared equals -1. So this is going to be plus 21. So I've got 28 plus 21. Well, that's 49. And then I've got -12i plus 49i, which is, what is that? 37i? Is that right? So 49 plus 37i. So letter A, is that right? Did I do something wrong? 28 and 21. That should be 49. Yep, I think that's right. Oh, this is 49. Sorry about that. That's 49. All right. I think, is that the last? Oh, no, we just started this section. Okay. So problem 2, now it's addition. Can you add imaginary numbers together? Okay, so in this problem, it says evaluate. So 4 plus, okay, it's 14, plus 20i, plus 19 minus 2i, right? So now I'm just going to add like terms together. So that gives me 33 plus 20i minus 2i, which is 18i. And I'm done. So remember, when you're just adding imaginary numbers, it's just basic addition. If you ever have an I squared, you just got to change it to -1. All right. Number 3, it says evaluate the expression. Okay. Remember when we started talking about negative exponents? We rewrite them right away without the negative inside. So I'm going to rewrite this as the square root of 25i times the square root of 81i. Now, the square root of 25 is 5, so this becomes 5i times 9i. So this becomes 45i, whoops, 45i squared. I squared is -1. So this becomes 45 times -1, which is -45. Done for that one. So you just have to remember imaginary numbers. A again. Number 4, it says evaluate the expression I to the 44th and write the result in the form a plus bi. Choose the answer from the following. All right. Remember, all we have to do is divide by 4, and then the remainder tells us what the answer is, right? So if I divide 44 by 4, remainder of 0. So what does that tell us? The remainder is 0. Because there's 4 solutions here. You can have I to the first, I to the second, I to the third, and I to the fourth. Okay. So I to the first is just I to the second is -1, I to the third is -1, and I to the fourth is I squared times I squared, so it's really -1 times -1, which is 1. Now we divide by 4 because that gives us where that ends. So for example, if I said, what is I to the 5th? Well, I to the 5th is going to be I squared times I squared times I. So it's going to end up being just I. So that has a remainder of 1. So if you have a remainder of 1, your answer is going to be I. If you have a remainder of 2, your answer is going to be -1. If you have a remainder of 3, your answer is going to be -1. If you have a remainder of 4, which is really 0, right? Your answer is going to be 1. So I kind of did it backwards a little bit. Okay, so, and you can, I mean, you could work it out. I to the 44th, you could go I squared, I squared, I squared, I squared, I squared. So you get the 44, but it's much easier just to divide by 4, I think. All right, next problem. It says subtract. So now we had polynomials. We talked about adding polynomials, subtracting polynomials. We talked about multiplying polynomials. So in this problem, it's just subtracting a polynomial. But remember that minus sign in front of the parentheses goes to everything, right? So if I was going to do this problem, I would write it out like this. I'd go x to the third minus 2x plus 3. And then I'd go plus a -1, 3x squared plus 4x minus 3. And why do I do that? Because now I know that that negative goes to every term. So this is going to be x to the third minus 2x plus 3 plus -3x squared plus -4x and plus +3. So now I have all addition signs, so I can just start putting them together. So that's x to the third. So that's gone. Minus 3x squared. So that's gone. And then -2x and -4x, that's minus 6x. So those are gone. And then 3 plus 3 is 6. So it looks like letter D for my answer. Yep, you're pretty sure it's D. It is D. Okay, so that minus sign in between the parentheses usually catches a lot of kids. All right, next question. Number 6, it says add and write the resulting polynomial in descending order of degree. Okay, so we have to write it in standard form. So I've got 8x plus 4 plus negative 11x plus 5. I don't have to leave the parentheses in here because this is an addition problem. So this is just going to be 7x plus 9. Uh-oh. What did I do wrong here? Am I not looking at this right? Oh, that's 11. Oosh. So that's going to be what? Negative 3x plus 9? Yeah, I suppose when I work too fast and I forget to write the right answers down or the right numbers down, it does make a difference. Don't panic. Yeah. All right. Number 7 says, which is a 4th degree trinomial with a leading coefficient of 3? Okay, trinomial means there's 3 terms. 4th degree means it has to have a 4th degree, the highest power is 4, and the leading coefficient is 3. So which one of those is that? Letter D? I agree with that. Letter D is correct because it has it's a 4th degree polynomial. It's a trinomial, so it has 3 terms, and the leading coefficient is 3. The leading coefficient is always the number in front of the highest power. Number 8, which is the product? So now we have to know how to multiply a polynomial. Yeah, exactly. You're going to FOIL this problem. Now, if I was going to do this problem, I would write it out more like this. I like to have the 2 terms in front. So I would go x minus 3 times x squared minus x plus 9. I like to have the smaller terms out in front. So now if I multiply the x times everything. So that gives me x to the 3rd minus x squared plus 9x. And then I have to multiply negative 3 times everything. So that gives me negative 3x squared plus 3x minus 27. And then I have to combine like terms. So I have x to the 3rd. I have a negative x squared and a negative 3x squared. So that's negative 4x squared. 9x plus 3x is 12x minus 27. That is it. So the reign of D is over. A lot of A's and D's today, isn't there? On there. I know. Okay. Number 9. Which of the following is equal to, uh-oh. Does anybody remember what we have to do here? Pascal's triangle. Yes, we have to use Pascal's triangle. So now Pascal's triangle: 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So this would be a 0, a 1, a 2, a 3. This is a 4th degree polynomial. So that's a 4th. So this is a 4th degree. So I know there's going to be 1, 2, 3, 4, 5 terms here, right? It's a 4th degree polynomial. It's going to have 5 terms. 2p to the, I'm going to have to write this smaller, else it's never going to work. So I always start off with the highest power. So I've got 2p to the 4th power plus, oh, this is a plus minus 2p to the 3rd minus 2p to the 2nd plus 2p to the 1st, and that's it. And then I'm going to add my other ones. So the 3t, so I have 3t to the 1st, 3t to the 2nd, 3t to the 3rd, oops, and then 3t to the fourth. Now, 2p to the fourth, that means I have to take 2 to the fourth power. 2, 4, 8, 16. So this is going to be 16p to the fourth. Oops. Okay. And then I have 2p to the third, 3t to the first. So that's going to be 8p to the third, 3t. So my second term, that's going to be 24. So 16p to the fourth, and then this is going to be 24p to the third, t to the first, and then my next term is going to be here, so that's going to be 4 and 9, so that's going to be 36p squared t squared plus, and I haven't put my Pascal's numbers in yet. Okay, so I know that that's going to be a plus, that's going to be a minus, and then I've got 2p to the first, so that's 2, and then 3 to the third, that's 27, so that's, is that 27? I think I'm right. 27 times 2 is 54. P to the first, t to the third, and then 3 to the fourth, which is 81. T to the fourth. Okay. Yes, I agree with you. And then I have to put my Pascal's numbers in, right? So I just have to, so this becomes a 1 in front of here. This becomes a 4 in front of here. This becomes a 6 in front of here. This becomes a 4. And this is a 1. Okay? So, whew, I'll let you guys multiply that stuff out. But I know the first term has to be, what is that going to be? 16 p to the fourth. I know the last term has to be 81 t to the fourth. And then the middle ones, you can multiply those things out yourselves. And it's pretty not readable. But I want to get to the last one. Is it B? Did somebody multiply it out? I don't remember what the answer is, but B seems like it could work. Oh, you just have to multiply the second one. So what was that? No, I can't even read my writing anymore. So 24 times 4, because I have to use the Pascal's triangle. So 24 and 4 is 96. So yeah, 96. So that would be 96. So yeah, it would be letter B. All right, and then the last, I think this is the last problem. Looks like I have more slides here, but oh no, I have extra ones on there. Yikes. All right, well, we're only going to be able, because we don't have much time left. It says factor by grouping. Remember, when you factor by grouping, you just put parentheses around. I'm going to change this to -25. And then I would pull out the greatest common factor there, which would be 3x squared. That would leave me with 5x minus 2. And then if I pulled out -5 here, I'm left with 5x minus 2. Then my parentheses are the same, so I factor that out. And that gives me 3x squared minus 5. So that would be factored using grouping. Whew. All right. That was a lot of math work. But as I said, if you take a look at the assessment, when I made this out, I basically went right along with, when I did a problem on the practice, I did one on the exam. When I did one on the practice, I did one on the exam. So they should look very similar. I didn't try to trick you guys on anything. So I will know who went through the review and who didn't. I mean, because it'll be obvious. The kids that didn't probably won't do real well. I know since it's multiple choice, there will be a lot of students that will just guess their way through. Well, You only get one shot at this. You don't get more than one. So make sure when you click to submit, those are the answers that you want. All right. All right, ladies and gentlemen, I gotta get going to my next class. You guys have a great semester. We'll see you back second semester if you're with us. Bye.